Hello, everyone. My name is Akash Shetty. I'm a data scientist at ApplyBoard. I'm also a big data program facilitator at McMaster University. So I'll be talking today about explainable AI, but more specifically towards building explainable AI or trusting AI products. So let me try this. Okay, that works. So this is the overview of my presentation. So I'll be talking about AI deep learning, its current stage, bias in AI, impact of bias in our society, trust, reproducibility, and explainability in AI, implementation of explainable AI, takeaways, and key resources. So the current boom in AI is primarily due to big data, computing power, models and algorithms, and GPU on chip. Big data has primarily transformed the technology approach in the way we store information, process, and analyze. Computing power is pretty straightforward, but I would like to emphasize that the latest chips can do over 10 trillion calculations per second, and cloud computing has made computing power more accessible and parallelization possible. Models and algorithms are growing rapidly, primarily due to investment in the field, and GPU on chip speeds up computation on deep learning applications. So these are some of the innovations in AI. AlphaFold, AlphaZero, big and better language models, autonomous vehicles with multiple different models for recognition, segmentation, and trajectory prediction. We are advancing quite quickly. But then comes this aspect of AI, which is all of those are enablers, but now we have something to pull it back. So we do face a problem of bias in AI. So bias in AI is a serious problem, and there are two kinds of biases. One is cognitive bias and the lack of complete data. So cognitive bias is a designer might unknowingly introduce them in a model and a training data set which includes those biases. So often the problem is the data. With cognitive biases, for machines we are talking about two, but humans have about 180 different cognitive biases. I suffer strongly from this effect called Google effect, which is the tendency to forget information that can be found readily online by using the internet search. Raise your hand if you don't remember your syntax for your Python code and use Stack Overflow. I would assume most of you do. So often the conversation about bias results in as a technical problem, but it is much more than that. It is due to human and systematic biases. Think about it. We use historical data. Historical data embodies or comprises of human and systematic biases. So bias can have serious social harms, loss of opportunity, economic loss, and social stigmatization. AI products can really influence your behavior. Just think about it. When you watch Netflix or Instagram, you're provided recommendation. These really influence your behavior. There's a great Netflix documentary called The Great Hack. It uncovers the story of the Cambridge Analytica scandal to enforce certain political or radical views. They call this group as the undecided. So they think using AI recommendation, they can change your perspective or views. So in the real world, we got to think of bias or problem in AI as a data problem, a design problem, and a use problem, and consequence of it in a society. A common problem is the data aspect, which is the sampling issues. We can sample disproportionate number of people or different ethnic groups, and this will just have discrimination backed into the data distribution. AI models in industry have intent to increase revenue or decrease operating expenses and are designed with that in mind. Over 90% of Fortune 500 companies use screening tools for hiring. So these tools are simple. They don't care about your gender or anything, but they just parse your resumes. You can be really qualified for a job, but if you have a fancy resume, you might not get selected just because the algorithm didn't parse it correctly. There's also a case study on job recommendations, especially if you look on Google in 2015, if you search the term CEOs, only 11% of the images were female. So when you see job recommendation ads, especially for higher paying roles, women don't get these recommendations. This will cause injustice and create digital divide in the problem space. So now I would like to talk about As much as we know that AI can perform very well, it's not 100%. Hence, to adopt AI, we need to know how it makes decisions. Certain decisions are critical and have massive societal implications. Hence, we should be able to trust in AI and be able to reproduce our results and be able to explain our models. Sorry, I gotta press this one. Yeah. So, trust. Should I let a car drive me to a destination? It is trust that allows us to live our lives. Trust in AI will depend on how human users perceive the system. Therefore, trust is a complexity reduction function. Let me just introduce some math here. Trust is a complexity reduction function. So let's say you have a pretty open day. You're trying to plan your day. You want to go play basketball. You want to go play with your friends or play video games. But the weather forecast says, oh, it's going to be a snowstorm. You got to stay indoor. So you just trust the weather forecast. You stay indoor and you work on your deep learning projects. Mathematicians do this quite often. Often when mathematicians and physicists do this quite often, when you're trying to drop something, you ignore certain aspects, such as air resistance, because you can trust that it will not have significant impact on your problems. So trust is inescapably linked to perception of risk in a given context. Modern trust environment consists of interplay between trust among individuals and rules and regulation that govern our behavior. If you have infinite computational ability to map out all the possible contingencies and enforceable in trust, that would not be a problem. It's basically economizing trust. But we do not have infinite computational ability, so that is our legal system right now. So this was an email sent by Bill Gates in 2002. So here you can see that he focuses primarily on trustworthy computing. So by trustworthy computing, what I mean by this is that customers will always be able to rely on these systems to be available, to be secure, and to secure their information. Trustworthy computing is computing that is available, reliable, and secure. So in terms of computing, as long as the goal was available when needed, reliable when used, and secure to ensure privacy. So is it possible to define trust in AI? So there's an attempt to do this. This is by the National Institute of Standards and Technology from United States. So to measure trust or to identify trust, there are 9 identified characteristics. These are accuracy, reliability, resiliency, objectivity, security, explainability, safety, accountability, privacy. These are all jargon terms if you think about it. So because all of these are from an engineering perspective. For user to adopt this, it is hard because we have to consider trust in terms of the user, not just an engineer. It has to be much more with an AI user than an AI practitioner. So trust in AI. So from a user's perspective, these engineering characteristics are necessary, but not sufficient for trust. These technical informations are contributing factors to their trust. One of the key methods they define in the draft that they're working on is called the trust user potential, but this idea is still vague and yet to be defined. The next aspect of this is reproducibility. Reproducibility is an interesting problem in AI. With model training in its initial phase to constant training, effect of data drift, our models will behave differently, and any inference or explainability will provide different explanation. Reproducibility crisis is debated and often not a spoken problem, as it's assumed to be known. It is extremely important to have reproducible results when decisions are made by AI systems in medical diagnosis, autonomous vehicle, or even defense systems. Okay, so these are some of the factors. You can think of having different OS, some different software environments and system architectures. Your mathematics are going to compute vanishing gradients or any of these things very differently. But there are other few factors. And the crucial one is, let me point this one, missing appropriate benchmarks. Because often you have research papers that are publishing a lot of groundbreaking research, but the one crucial thing is that they don't have the code or data publicly available. It's either protected due to IP, intellectual property, or due to sensitive data, but this makes reproducing results quite challenging. So now here we get into explainable AI. So what is explainable AI? So explainable AI explains decision-making of AI systems. Quite a lot has been spoken over the last 2 days. If you had listened to the conversation by Sharon, she had a really great talk yesterday. And there were some other interesting methods that were discussed on this. So if you think of an AI system as a black box, you have a data, you could have a machine learning or deep learning model. Some random magic happens that is often called black box. You have an AI product, and then a human user makes decision out of this product. Sorry. So now you have to ask, who are the users of this AI? So an AI user could be a business owner, a customer support, IT operations, data scientist, or regulators. A business owner has a simple question. Can I trust our AI decisions? Why? In terms of monetary benefit. Customer support, how do I answer the customer complaint? For IT and operation, how do I monitor and debug this model? Data scientists often wonder about, is this the best model that can be built? And regulators are primarily worried and concerned about, are these AI systems fair? So this is what explainable AI tries to do. So basically with the real world, we get some data. Again, we go through the same ML or deep learning models. We have a black box, but to this black box, we add some form of explainable technique. And then you get an AI product, and human user may probably do some informed decisions here. Next is this is an example of explainable AI using Lime. So you can see this is basically running Google's Inception algorithm on a dog or a Labrador playing guitar. You have explanation for playing electric guitar, explanation for playing acoustic guitar, and explanation for why it identifies a Labrador. So there are two kinds of explainable AI techniques. One is model-specific techniques, and the other one is model-agnostic techniques. Model-specific techniques deals with the inner working of the model to interpret its results, and model-agnostic techniques deals with analyzing the features. I'll explain this further. So in terms of model-specific approaches, work are based on specific structures. So we try to reverse engineer the features. So basically we have calculated, let's say a neural network, we have computed the weights. We try to reverse engineer how these weights were computed so we can explain the results. There is a trade-off between this. The more you try to explain, the more information you lose, or more accuracy you lose. Although model-specific models is that it allows us to get deeper understanding of the decision, having known the internal workings of the model. So here's like a flow chart of how a model-specific technique might work. So you have a data that flows through an AI model. You have prediction and you have explanation. Primarily, you get the explanation by reverse engineering this AI model to see how you got this prediction. Few examples of model-specific techniques are tree interpretation, slim model, and deep lift. And let me just touch model agnostic and then I'll get back to those things. So in terms of model agnostic techniques, model agnostic methods do not take into account of the structure of the model. They can be applied to any machine learning algorithms and work on a black box model approach. They can obtain explanation by perturbing and mutating the input data and obtaining sensitivity of the performance with the respect to original data performance. So it's interesting here, that what you're seeing as explanation is not a true explanation of features. Rather, it is trying to explain the local sensitivity of this model. So given in this image that we just saw from Lime, which is a model agnostic model, you're looking how a model might interpret at that region. It's not a global aspect of it, but rather saying how the model has been perturbed in a certain region. These are some examples of model agnostic techniques. So primarily focusing on sensitivity analysis. So you're looking at how sensitive your models are. You can try to look at this case in a false positive case, or a case when you have a situation where you don't want this specific prediction to be made. You can look at sensitivity analysis. Lime is a very popular technique, as well as SHAP. SHAP gives you a global attribute of how certain features are important. But if you want to calculate the true importance of feature, nothing explains better than a decision tree. It was interesting that yesterday somebody mentioned about enriched explainable neural networks. I didn't have enough time to look at it, but I've included in my resources, so you can have a look at it and implement it yourself. So code examples for explainability AI. So I have all of these models that I've shown here. I think they'll take more than 30 minutes to explain them by itself. So I've added some code examples here with resource papers and so on. So you can visit this link and access all those materials. So now let's get to the core of the matter. So we have bias in AI. We know to adopt AI for the masses, we need to trust it. And not only trust, we also need to reproduce our results. And once we reproduce the results, we need to be able to explain our results to regulators and to AI product users. So this is one way to mitigate bias. You need to start thinking about establishing a culture within your organization or team. So be aware of the context in which AI can help correct those biases. Establish a process and practice to mitigate these biases. Have a fact-based conversation. Look at your data. Maybe you have data which have certain section of the population, not the global population. So you want to look at the specific population group and just determine that the risk in this population level might not be that high because they have quite a bit of data. But on the other case, the risk might be quite high because you do not have enough sample size. The main goal would be the point number 4, to fully explore how humans and machines can work best together. And the last aspect would be invest more in bias research, make more data available for research. So within your organization, have a conversation of how to have an ethical series or ethical debate within your coworkers. Have a monthly discussion of looking at your data, identifying how your different data groups are split and what are the different data types you have. Here are other few techniques with mitigating bias in AI resources. So I would highly encourage you to look into these AI principles. So OECD, Google, and Facebook have different principles and methodology that you can follow within your organization to have much more standardization in these practices. So in the end, I want to end with key takeaways. So bias in AI can have significant societal impact. So you have seen you can have loss of job opportunities, especially some of the things that we don't even consider are social consequences. Aspect of social media platforms where we are getting curated contents of tweets, not chronological order. You might not follow somebody, but you're given the same narrative. This can really influence social behaviors. So trust in AI is a significant aspect where you need trust to adopt AI in the masses. If you want to implement AI in the health industry or in medical diagnosis, you want to have users trusted, not just the practitioners who develop it, but rather the users who use it. Explainable AI can help AI practitioners to understand their models and help human users interpret results better. So these two are connected. And this one is the last one where you have to develop a framework within your organization. I stress on this more just because often this is thought as a waste of time, or we do not have enough resources because organizations are focused more on increasing revenue or intent to decreasing operating cost. Focusing on ethical AI will actually help us to prevent risks that we might induce just by creating AI products. And to sum it all up, I want to highlight these resources. So most of the talks that I have from information that I've shared from you is from this paper, Trust in Artificial Intelligence. This is by NSIT. I would look at this paper by Francis Chollet. He's the Google researcher who worked in developing Keras library, so on the measure of intelligence. In this paper, he primarily talks about general artificial intelligence. So this tries to measure how can we measure intelligence in an AI product or even in a given model. Why I should trust you, I think it's a great name for the Lime paper. These are some other techniques. I would like to keep, this is the last slide. I just want to ask more questions on how people here are thinking of ethical AI within their organization, and what approaches have you done to tackle or try to have explainable AI within your organization? Thank you.